Okay, so here is my data Vox circuit. So we've implemented this, and you can kind of see here's the output from the generator, and if I reduce it enough and then turn it up and down, you can see that it's working. There's a lot of distortion actually. This generator is not happy with the transformer as a load, and I think it's I don't quite know if it has something to do with my diode bridge on the other side of the transformer, or if it's just the fact that these generators are not very strong on their outputs. So keep digging into this thing. Okay, this is a really great circuit here. I've changed it completely. I've decided to use a PMOS because what was happening is that the transistor, the junction transistor, was loading the output of the transformer in a nonlinear way vis-a-vis these diodes, and the waveform looked distorted when I was transmitting. So PMOS works pretty good. So I reduced the capacitive coupling dramatically. So these are 0.1 microfarads, and I have a bleeder, a 1 meg bleeder resistor. You can see the schematic here, and this is a real snappy. At 800 millivolts, it kicks over, and 600 it shuts down. So actually 700 millivolts kicks over because of the diodes. And you can see that the waveform is not at all distorted, which is good because any distortion on this waveform is going to end up in my transmit signal. So the important thing, I think, for these automatic PTT circuits is to make sure you don't distort the transmitter. So the PMOS is the way to go, because no input current is required to make it work. You just need a little bit of voltage, and you got to bleed it right there with the with the 1 meg, and this is doing the job. All right, so here is the interface. This is a Vox with the MOSFET, and there's the my homemade 20 meter single sideband transceiver. The VFO is stabilized. The hard part about this radio is tuning, knowing exactly what frequency you're on, because it's not synthesized. So I've got my signal generator set to 14.095 with a marker pip over here that I watch, and so you can see all of the signals coming in, and I'm logging them left and right, and I'm due to transmit pretty soon. And I've been transmitting. I've been making some hot people have been receiving my station. So we'll continue. We'll be next on the queue at 15. What my equipment thinks is 1500. It kind of looks like I'm off by maybe 200 hertz or so as to the actual receive frequency. So it's all right. We'll give it a shot. I have a DDS VFO that I think I'll add to this thing. And over here, you can see how I ended up wiring it. That is the, this is all from the radio. Ground is actually radio. Oh, we're on the air. So we're transmitting right now, that LED and this light here on the panel. Transmitting. Okay, so we'll see how that goes. And this is the schematic, again, for the PTT audio interface. Okay, so this is pretty cool. Anyway, the band is pretty quiet right now, but we're heard in a few places recently, so we're getting heard. Pretty neat. If I go back 1 hour, let's see where I tried this earlier. Oops. If I go back an hour, is that an hour? Anyway, maybe more. I was heard by quite a few stations earlier too, so everything seems to be working. And here we are transmitting actually automatically. It's interesting because you gotta let the VFO stabilize, but then we're good. So this thing's working out pretty well, let's say. And that FET there for the box is working out really well. So we'll have to put this onto a circuit board pretty soon, so it's a little more permanent and robust. Okay, I found first of all, for the LO, I found a really nice amp in my collection of amplifiers. So I've got this Mini Circuits low pass filter. It is a, you can't read it, PLP 21.4, 21, basically 22 megahertz low pass filter. This is a 20 dBm amp, so this is a good driver amp. Its IP1 is 20 dBm, so I only want 10 out of it, so it'll be fairly distortion free. Here's the DDS and the balun on the output. And then there's the control wire. So when I check this on the spectrum analyzer, it's super clean. I mean, the first LO. So I go from the output of here to this guy to through the filter. Harmonics were, first harmonic was less than 45 dB down. So I think it's fine. So now I want to move the automatic TR switch / audio isolator circuit and this stuff into one enclosure. So I've got this gray enclosure. It's got to look good because it's going with this radio, which I built from scratch and designed everything in. And I like my radios to look a certain way when I make them from scratch. It's kind of like, you know, people who make custom automobiles or what have you. I like everything to look good. So I found these leftover cable clamps. So I think I'll clamp my audio cable to my computer in here, clamp the cable going to the radio here. I have 12 volts from the radio, so that should power this and easily this stuff. And I think I'll do SMA on the output for the LO. And then I think this could be the transmit audio. And I'm going to use this jewel light for the PTT light because that radio uses light bulbs, not LEDs, and I want to keep with it. I've got the handle here, which will be awesome. It adds the look, and as well as it makes this really convenient to move around and stuff. I like to put handles on stuff I make. So here's how it's going to look. Transmit light, transmit amplitude, LO out. And as for reprogramming this, I think I'll just let it, you know, I'll expose the USB connector. I'll have it at the top here, so all you have to do is open this lid if you want to reprogram the LO. But since I'm going to be doing data, it'll be at the same frequency all the time. I'm going to set it to the whisper frequency to start, and then if I have to change it, I'll change it. And there'll be room for expansion. I'll be able to expand it like I've expanded this GPS clock. So that's what this is right now. Okay, so here is the box thus far. Really like the way the audio board turned out. So there's receive, transmit audio, and this, although it's hard to tell, that's your transmit PMOS FET there, and the voltage doubler, the 1 meg, all that stuff. It works great. Inside the box, we have Arduino, a cheap Arduino, DDS board, amp, buffer amp right here. Over here is a low pass filter to clean up the LO. The LO comes out the front. This is the transmit gain. This light indicates if you have PTT transmit. There's your connection to the microphone that I use. And then here's the audio connection, the computer. And all these are really nice Hubble gaskets, or the Hubble strain reliefs. So I just verified that everything's working just fine. And the next thing I'm going to do is just mount all this stuff up, screw it down, and then do the rest. Okay, here's the final. So I've wired it all in, and there's the test board. I have a service loop for the test board, as well as the Arduino, the driver amp, the low pass, and I've decided to bus all the power wires right up here so that I can access them more easily. Alright. Okay, here's the outside, and I've got to add the labels to it. I added this vintage NEMS Clark receiver label for fun on the top. That looks good. Here's your LO out. This plugs into the microphone. Transmit. PTT light, transmit audio, and then this goes to the MacBook. And, you know, gotta clean up some of the marks on the sides of this box, but otherwise it turned out alright. Alright, so I've drilled these two holes in my front panel here for my 20-meter single sideband transceiver, and I put this bypass. And what I'm going to do is I'm going to feed the output of the VFO into one, and then this guy will go into the front end mixer right here where the VFO currently goes. Now what I'm doing right now is I'm also looking at my BFO oscillator. I think it's off frequency a little bit, so I'm going to adjust it and make sure it's all tuned up. This radio, built this 10 years ago or so. It's really well built, modular style. It's been working perfectly without issue ever since. It's over 40 watts of output. Here's a PA. I probably get a little more out of it with what I know today, but I'll worry about that for another day. I'm just going to work on the BFO, tweak that up a little bit, and then hook up my bypass and test it out. I'm just radiating a signal of 1430 into the receiver, and you can hear there's 0 beat and not much below that. So I think it's single sidebanding quite nicely. Yeah, okay, that works pretty well. So that's tuned up. Now we're going to check our cabling for the VFO bypass. Alright, so now we're going to do there we go. Looking good. So the bypass works. I'll do some labels. Watch this. Of course you could just knock that off. So I'll do some labeling here. And then the radio is all set. Button back up. Press it back into service. And two was I had to add a heatsink to the 5-volt regulator over here because it was overheating, powering that DDS board off of 12 volts. So use some epoxy and heatsink compound that ought to hold it in place. Drilled, as you can see, vent holes there and up here to let the air flow through. We'll give that a shot and see how that works.